Welcome back, everyone. In this lesson, we're going to go ahead and take a look at dictionaries. Dictionaries are another type of structure, a collection basically, that allow us to use key value pairs. These are sometimes called hash maps or associative arrays in other languages. Let's get started right off the bat and create a brand new Python 3 notebook. And I'm going to call this one 006 Dictionaries. There we are. All right, so to create an empty dictionary, should have put my hashtag here. And they're sometimes called dicts. So dict1 is going to be open, close curly braces. That creates a dictionary. And of course, dict2, we can call the constructor by calling simply dict. And that creates another dictionary. Typically, what we do with dictionaries when we are practicing, we create one by providing the keys, which if they're strings, they go in single or double quotes, followed by a colon, and then the value, in this case, say Bugs Bunny. Now, these do not have to be simple data types, and they don't need to be the same type. So I can create a key called age and give it a numerical value. I can create a key called courses and give it a value that's a list. So I can say math and physics, in quotes, of course. Let's take a look at student. And you can see it actually spits out the dictionary. I can get the type of student, and we can see it is, in fact, a dictionary. Now, to access any particular key, I can refer to that, to any particular value. I mean, I can refer to that particular key. So I can say student name, and notice it gives me Bugs Bunny. Of course, you can say print student name, and you may recall that if you do it this way, it drops the quotes. Okay. I can type in student age and get the age. I can type in the student, courses. Oops. And get the courses. Now, if I want to say a particular course, remember that lists, tuples, these constructs are zero-based indices. I can type in, the courses that fetches the array, and then I can actually index number 1, which would be physics in this case. Okay. So hopefully so far it's pretty easy. If a key doesn't exist, it will return an error message. So I can say student, for instance, phone. We did not create a phone, so we get an error message as expected. We can use various methods that are built into a list. If I type in student dot and press the tab key, you can see there are a bunch of methods that are built in. There is a pop. There's a get, items, keys. Let's take a look at some of these. So I'm going to use the get method. So I'm going to say get, as opposed to directly indexing it, I'm going to use get. And notice it returned Bugs Bunny again. Now, the benefit of using something like get sometimes is that if something doesn't exist, it does not return an error. So if I try to get phone, notice that we don't get anything back. We don't get an error. We just get nothing back. Okay. And of course, you can type in get and go after courses, which will return the entire list as before. Okay. Pretty cool. If you do a print statement, in case you're wondering with student.getPhone, and we know that there was no phone number, it actually returns none, just so you see. We could, if we wanted to, as part of our coding, return a default value. Okay, so let me put a command over here using a default value as a second parameter. So I could say, for instance, print student.get and phone. We know that returns none by default, but I can put in, for instance, not found as the second parameter. And in this case, it actually returns not found. Now, what if I actually want to add this telephone number in there? I can use the update method. So I can say student.update. So I'm actually updating this dictionary. And in the parentheses, you basically add whatever else that you want in here. So I could add, for instance, a name. Let's say Daffy Duck. And let's say age is 57. And for Daffy, we're going to add a phone number. And we're going to make it be a string 703-555-1212. Shift Enter. Oops, I forgot to put my quotes. Glad that we got that error message. And then let's take a look at student again. So you notice that I have name Daffy, age 57, courses, math, physics, phone number, etc. Because I used the name attribute, which I had used earlier for Bugs Bunny, and the age attribute, you notice that those were replaced by Daffy and his age. And of course, we added an extra field. Let's go ahead and do a student.getPhone now. And we get the telephone number back. Okay. Okay, let's take a look at what can cause problems for us. Let's go ahead and create dict1 again, and I'm going to let this be name : bugs. And as you recall, this gives you an error message because the string must be, or the key in this case must be in single quotes. Let's go ahead and rewrite this. I'm going to make it be 1 : bugs. And notice this time that I actually can work with it because 1 is a number. So that's perfectly fine. As long as it's a numerical value, that is an integer, you can do that. To delete stuff. So I can say delete, del, student, and then refer to what I want to delete, in this case, age. Let's take a look at student after it's done. Notice the age was removed. Okay. I want you to know that the delete operation is not just something particular to dictionaries. If I create a list, let's say, I'll just make it be test and sample. Let's take a look at the list. I can say delete li, say sub-0. And that should delete the test value there. Let's actually verify that. You can see that only sample came back. So this is not something particular to dictionaries. Let's take a look at using pop method to return the value. Pop removes the value from the dictionary. So keep that in mind. I can say name is equal to student.pop name. And let's do shift enter. Let's take a look at name. We can see it's Daffy Duck, but if I take a look at student now, you can see that the name was actually removed. Okay. As with everything, we can take a look at the length of this thing. I can say print the length of student, which at this point is 2 because we only have 2 elements left. Courses and phone. Okay, so that's an option that you can do. If I want to view the keys, just the keys themselves, I can type in print student dot and call the keys method. And I can see my keys are courses and phone numbers. Let's say I want to view the values. As you might expect, you can call print, not that print is necessary, but it's prettier this way, and call values. And there are the values. So we can see that the list, which includes math and physics, came back, as well as the phone number. We can also view both keys and values. And we can do that by calling on items. So I can say student.items. And that returns both the keys and the values. We haven't officially covered for loops and while loops or loops in general, but let's take a look at looping through a dictionary. I can say for k, which is just a placeholder in student, it's one of the most powerful features of Python that we can loop through a collection without having, an integer index of any kind. Let me make a comment over here that this way it only gets the keys. So for k in student, print k. That's why I use k for keys, basically. All right, what I can do is I can use two placeholders. So I can say for key, comma, value in student.items, that collection that we saw a bit earlier, print the key and the value. And I want to point out that the key and value is just two variables. I could say for k, comma, v if I wanted to. And this way, as you can see, I get the key followed by the value over here. If I want just the values, I can say for v in student.values. And type in, say, print v. So you notice that I could, in this first loop, when I say for k in student, I could say for k in student dot, keys, but that is the default. That's just something for you to keep in mind. The last thing I want to cover is we will be going over creation of libraries and creating our own libraries, etc., and importing these when we need them. There is a special library in Python that is called the this library. It was written by Tim Peters, and he refers to it as Zen of Python. It's nothing more than a bunch of print statements. To import a library in Python, you simply use the import keyword, and you can say import this, or whatever the library's name is. In this case, if I do import this, it comes up with this so-called Zen of Python. And this is what's recommended to developers to always keep in mind as they write code in Python. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Some of it gets a little bit silly, however. I apologize for this silly notification. It says, for instance, although never is often better than right now. Now is better than ever. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. So it's just a bunch of print statements. Then we're going to be learning how to create our own libraries later and import them, and of course work with existing libraries. I hope you enjoyed this lesson. Thank you for being a wonderful audience as always. And if you're enjoying these, please share with your loved ones and friends.